Hi everyone. I hope that you guys are here. Even if you're not here, I already told you guys that I'm sorry. I will be a bit late, due to certain things. By the way, if anyone here, how do I know is anyone here? If anyone here, can you give me some response? If anybody's here or not here, but yeah, whatever it is, this live video will be it's actually will be in my YouTube channel. So if you miss anything in my live video here, you will be you still can watch this video later, late night, or after this video, or after this live video has finished. So is anyone here? Yes, all right, very good. So by the way, everyone's I hope that you guys are doing well, and everyone is actually not my student. Welcome to this YouTube channel and welcome to this live video. And for today here, I'm going to teach you guys at math for chapter 2. We're going to revise that thing for chapter 2 here. So for chapter 2, we have all these things. But before I told you what to be in the chapter 2 and everything, I've finished mark your paper for all of the classes. Okay. And it's what I expected. Everything is so predictable. For some reason, everything is quite predictable, and only 2% get the highest mark, which is only 2% get full mark. That's kind of surprise, and I'm not surprised who got it. Okay, that's what I already expected. And there's also 2 students who get the lowest mark, which is only get 1 out of 50 marks. Okay, so that's the thing, and that's for your information. But I hope that that thing not going to disturb you for your next paper. I'm just gonna tell you. I'm not telling who. I'm not telling whatever it is. But now let's focus on the AdMath. Okay. So for the AdMath here, for chapter 2, like I told you, we only need to talk about these 7 subtopics. Not really subtopic lah, but this is only 7 things that we need to talk about. Okay, and it may be a bit tough because your method is a bit different than my method, and my method here is not really exactly the same as in the textbook, but it's the one that make you can understand easier. Okay, so first of all, in the chapter 2, I'm gonna start by the way. Okay, in chapter 2 quadratic additional mathematics here, the first one we are going to talk about the simultaneous equation. And when we are talking about simultaneous equation, we are going to talk the simultaneous equation between a linear equation and a nonlinear equation. So I'm just going to straight away put over here is a nonlinear simultaneous equation. Why is that? Because later we'll see. Because in your additional mathematics syllabus, only these things that will be related. Between nonlinear and nonlinear is not really gonna come out in your exam. But the one that must come out in your exam is between linear and a nonlinear. So what do you mean by that? Whenever you see a simultaneous equation, please do remember, and please do, how do I say, just straight away, the word simultaneous equation, just remember these keywords here, which is, it is called as poise. P-O-I-S-E, poise. Always remember, tomorrow when it comes with your exam paper, straight away remember poise, poise, poise. What does it mean by poise here? So the word poise here comes with this letter, P-O-I-S-E. It means this is a short form of the abbreviation for P as a point, O as in off here, I is intersection, and S is a simultaneous equation, and E is equations. So poise means that whenever you see a simultaneous equation, you are looking for point of intersection, or the vice versa. Whenever you want to see the point of intersection, you are finding the simultaneous equation. Whatever that I told you here is exactly the same like my previous video in the playlist. Go look on the playlist. The first video in the playlist is actually there. So please go have a look on it. Okay? So what do you need to understand about these things here? Which is the one that you need to understand is you need to substitute linear into nonlinear equation. That's the most important step. If you substitute the nonlinear into linear, it's gonna go wrong. Trust me, it will go wrong. By the way, is it everything okay? And the one that's not related, yeah, thank you for here. Thank you for being here. But how do you know can you look at me? How do I know that? Did I put the camera on me? I didn't see that the camera is on me. It's okay lah. Alright. So once you already understand that between linears, you need to substitute linear into nonlinear. You need to know, of course, the difference between linear and nonlinear. I already showed you this example. Refer back to my first video. You're going to be okay with it. These are the things. And the steps here. Remember, if possible, try to organize your working first, which is you have left working, right working, left side, right side. You do know, and make an arrow if you wanted to. Make everything is organizable, and everything makes everything so neat and tidy. Alright, because this is at math. Later you're gonna mess up the whole equation, you're gonna mess up the whole working. And then after that, use an easier form of linear equation to substitute. Rather than you use 3y minus x equal to 4, if you make x as a subject, it's only have 3y minus 4. It's easy. But rather than you use y as a subject here, it's going to be 4 plus x over 3. When you have a fraction term, your working would be a bit messier, because it's a bit more complicated. So that's why I suggested you to do and to try to use an easier form or easier expression of the linear equation. And if you have an example of a nonlinear equation that's a bit hard and a fraction and everything, make sure you try to eliminate the fraction first. How? You multiply the LCM between the denominator here. That's what I do. And I already give the example. And I already showed the example, everything in the first video. Go back to my first video. You will be okay. Alright, just listen one by one. These are also the same example. I'm just hope that you guys tomorrow you will be okay. Just following my steps here. You know what? I divide the working into two steps, which is I divide into two partition. Left partition as in linear working, and right partition as a non-linear working. So the right is the quadratic term. That's the thing. Okay, I hope that you guys are okay with it. And now let's straight away go to the next thing, which is the quadratic vertex form. This one I already posted a video regarding this thing. So quadratic vertex form here, it means that we want to convert the general form of the quadratic, change it to the vertex form of the quadratic. What does it mean by vertex form? Vertex means it's like the turning point. So we know that the quadratic is either smiling or a sad face. So when you change this form of equation, you straight away will get the coordinate. You straight away will get the coordinate of the turning point just by looking at the equation. No need for you to sketch the graph. Of course, when you sketch the graph, then you will know where is the stationary or the turning point. But from here, you just identify and you just going to look at it just from an equation. That's the thing. Alright, so the equation here is y equal to a bracket x minus h close the bracket square plus k. These are the method here where you learn in your textbook is CTS, completing the square. Okay, alright, so that's the not the one that I'm going to emphasize here. I'm not going to emphasize the completing the square. I'm going to emphasize on another method. But what I'm going to be really strict here and very highlighted here is that the formula of the vertex form, right, or the general or the form of the vertex here is that it must be y equal to a bracket x minus h close the bracket square plus k. Minus is part of the formula. Minus is not part of the h. Minus is, or negative here, is part of the formula, not part of the h. So whenever you have the value of h is positive, when you put it there, it will be minus positive h. So minus means positive, of course it's going to be negative. But of course, I already showed you the example. And why h and k here is so important? Because h and k here is the coordinate, which h is the x coordinate of the turning point, and k is the y coordinate of the turning point. It's either minimum or maximum. This is minimum and this is maximum. Alright, what method I'm going to use? I'm going to use negative b over 2a method. How to do? Straight away remember that the coordinate of the h, or the x coordinate of the turning point, is equal to negative b over 2a method. That's one of the formula. You're going to have more formula later. You're going to have more method once you learn more on the differentiation. But for now, here is negative b over 2a. And if you already get the value of h, you can substitute the value of h as x into initial equation to find the value of k. That's what I do. To talk about the example here, let's see how do I do. We know that y equal to x squared minus 5x minus 6. Always identify the value of a, b, c first. So a equal to 1, b equal to negative 5, c equal to negative 6. So straight away apply the formula h equal to negative b over 2a. So negative multiplied by multiply by with b, which is b is negative 5, over 2 multiply with a is just 1. So negative means negative become positive. So positive 5 over 2, or you can write it as the decimal, which is 2.5. Even if you want to write it as fraction also can. But this one I'm just showing to you with decimal. So once you already know the value of h, how to find the value of k, you substitute this value of h inside the initial equation as x. That's why I put here x squared minus 5x minus 6. I put a bracket here, bracket square minus 5 bracket minus 6. Which is, now you substitute it as x here, which is 2.5 squared minus 5 multiplied by 2.5 minus 6. And you do all the working in the calculator. Make sure you write it properly, you press that thing in the calculator properly. You're going to get that your value of k is negative 12.25. So straight away, I do know that when the graph is smiling, since the a is positive, the minimum point must be x equal to 2.5 and the y minimum must be negative 12.25. And that's why I wrote here in vertex form, which is a bracket x minus h squared minus plus k. So a equal to 1, even if you don't write 1, it's also kind of problem. X minus h, which is h is 2.5 square, and k is minus 12.25, or is in the fraction term here. So that's what I do. Okay, I hope everything is clear. Alright, I really hope that everything is clear, and that's how we do in the vertex form here. Alright, so if you already understand that thing, I'm going to show it to you. This is another method. How do you want to see another method here? Go look on my previous video. On my second video of the playlist, it should be there, which is I already put over there as a quadratic vertex form. And yeah, I'm going to continue on the next things. Which is continue on the next thing here is sketching the quadratic graph. So to sketch this quadratic graph without modulus first, just imagine that you want to sketch a quadratic graph, you must know this 4 component first. List down these 4 component before you do the sketching. What is the 4 component? Number 1, the shape. The shape of the graph either is smiling or a sad face graph. Which is smiling here is when the a is more than 0, or you could understand that a is positive value. If a is any positive value, that means it must be a smile graph. But if a is a negative value or a less than 0, it must be a sad face graph. Where the sad face graph, it have the maximum point, and the minimum and the smile graph here is actually having a minimum point. That's not going to be that hard, but you already understand that thing. Okay, that's component number 1. Component number 2 is the y-intercept. Okay, which is y-intercept here is the coordinate where graph intercepting the y-axis. That's clear, not going to be that hard. So how do you want to know it? You do know that whenever you want to find the y-intercept, you make x equal to 0. Oh, okay, alright, that's fine. But to make your life is easy, just straight away imagine and straight away take the value of c in the equation. Because the value of c in the equation is your y-intercept. It's almost applicable to the method of straight line graph or straight line equation. Y equal to mx plus c. The c is your y-intercept. Same goes to here. Y equal to ax squared plus bx plus c. C is your y-intercept. That's the thing. So we do know that is example y equal to x squared minus 6x plus 9, a equal to 1, b equal to negative 6, and c equal to 9. Straight away, this is your y-intercept. And the coordinate of your y-intercept is 0, 9. That's why I pinpoint over here, that is the example of it. So now you know. Okay? So right now, how to find your x-intercept? So that's why I already put the tips here. If you want to know your y-intercept, x equal to 0, but I already show you an easier method, just straight away the value of c. But if you want to find your x-intercept, your y must be 0. So how to know it? So you know that it is actually the coordinate where graph intercepting the x-axis, okay. But you also need to know that it's also known as roots. Don't be weird whenever the question asks about roots. Roots is also x-intercept. That's so obvious. Right? That's quite obvious. How many questions in the paper? I'm not sure. I'm not the one who make the paper. Okay, all right. So so that's the thing. All right. So we have two methods here. Method number one to find the x-intercept, which is method number one is by formula. This one, I think it would be given. I believe in the real IGCSE, the formula is given, which is x equal to negative b plus minus square root of b squared minus 4ac divided by 2a. It's part of the formula. I don't want to say anything about it. Okay. But method number two, it's the method that I highly recommend that you, and I never see any kind of student who not using this method when it's come to the real IGCSE, which is this method is by using a calculator. Your calculator here, it's either Casio. I'm just going to say the Casio brand here because that's the mostly used brand of calculator here in Malaysia. Maybe if you are the viewers from outside of Malaysia, I'm not sure whether you use the Texas Instrument or not, but I'm here just to highlight on Casio calculator method, which is it's either the series number here is either 570MS or 570ES, or the class width calculator, which is that's the newest one. Okay. Alright, so how to know here, which is you need to follow this method one by one. If 570MS here, so this on top here is written the 570MS. You press on first, you press mode 3 times. 1, 2, 3. This is the mode, and then you press mode 3 times. After that, you press 1 as in the EQN or equation. EQN here stands for equation, which is this is number 1, then you press number 1. Then they surely gonna ask you for an unknown, so you need to press mode one more time. Press mode one more time, they're gonna ask you about degree, or they just write there is DEG. DEG stands for degree. So you press number 2. Why 2 here? Because ax squared plus bx plus c, the degree of the equation here is 2, which is the power of 2. So that's why you press 2 here. Then they're gonna ask you the value of a, b, and c. How do you want to press it? Just press the number and then press equal. Press the number, press the equal. Press the number, press the equal. It will be appear. But if you are using this calculator, this is quite easy. You press mode, and then in this 570ES, you need to press number 5 as in EQN. But for the class width, I can't get it here in the computer. I can't get the emulator for that. So you need to press alpha A for class width calculator. Alright, alpha A, which is you press alpha and then A is around here, I'm not sure. And then after that, that's going to appear as the equation. Alright, you press here, you press equation, and still you're going to choose as ax squared plus bx plus c, or the degree is equal to 2, because that is your equation. So you press number 3, and here it will appear a, b, and c. Then you just insert it by pressing equal. Alright, I hope that my explanation about this calculator method is quite clear. Even if it's not clear, try to repeat this live video again and again and again. Okay? Alright, so I hope that's quite okay. And now let's see it with the example, which is the example here. Y equal to x squared minus x minus 6. You know that the value of a equal to 1, b equal to negative 1, c equal to negative 6. So if I press in the calculator here, I just press a equal to 1. And then press equal, b equal to negative 1, press equal, and c equal to negative 6. And then straight away you get the first value of x equal to 3, the second value of x equal to negative 2. Or if you are using this calculator, the same thing. Okay? It's the same thing, this one, yeah. X equal to 1, b equal to negative 1, and c equal to negative 6. You're still gonna get x equal to 3 and x equal to negative 2. So you do know that that's your x coordinate where it is intercepted x exists, and that's how it is. Okay, so that's how you want to find roots. And the fourth component here is how you want to find the coordinate of the turning point. How to do, which is from my previous topic, which is quadratic vertex form, where you need to do it by completing the square, or the method which is negative b over 2a method. That's the one that I do. Okay, that's the one that I do, and that's the one that I did, and yeah, that's how we do. So this is the example. I'm just going to show it to you one example. which is the first example here. A equal to 1. Get the first component, which is A equal to 1, B equal to -5, C equal to 6. The first component shape of the graph. Identify the value of A. A is positive 1, so it must be smiling. And then find the y-intercept. Y-intercept equal to C value, which is C value equal to 6, so it must be 0, 6. Your x-intercept, press in the calculator, you get 3 and 2. That's how I do. You can press it in the calculator, you can check here. Or you can refer to my previous video. And then after that here, you do the negative b over 2a method, then you're going to find that all the minimum point here is showing here, which is x coordinate is 2.5 and the y coordinate is negative 0.25. So from here I pinpoint here, which is y-intercept, pinpoint x-intercept 2, pinpoint x-intercept 3, and the minimum point happened at 2.5 and the y minimum here is negative 0.25. I pinpoint here and then I cross the smile. I draw the smile shape graph here. And that's how we do sketch the quadratic graph. You can refer to the next example in my previous video. Okay, all right, in my previous video. I hope that's clear now. Okay, to prove that, ask us to prove or show something like that. What do you mean like that? Teacher can explain question that asks us to prove or show something like that. What do you mean something like that? Okay lah, all right, don't worry, I have more. Which is the next one is sketching the quadratic modulus graph. All right, so sketching quadratic modulus, you need to understand what does it mean by modulus first. All right, so you need to understand modulus, it means that must be all positive value. So what did I wrote here is similar method to sketching the quadratic graph. It's just that you need to reflect the graph by x-axis as a symmetry line. Okay, so these are the things that you need to understand first. Where did I put it? Where did I put it? All right, I did not put it here, but that's fine. The one that I put it here is actually the one that I need you to understand here is y equal to modulus. When y equal to modulus, what does it mean? Y coordinate must be all positive. All right, must be all positive. So when y coordinate must be all positive, so if we have a graph here, okay, if we have a graph here, this is x-axis, y-axis. So when y must be all positive, that means all the region and all the graph must be on top. That's the reason why the graph, you need to reflect it back towards the top. That's the reason why. Okay, because y coordinate must be all positive since that y is a modulus. So that's the thing. So how do we sketch here? And let me show it to you an example. The same method of 1 by 1. What you need to do here is get the component 1 by 1, which is the first component here. It's the, ignore the modulus first. Ignore the modulus. The first component here is A equal to 1. That means must be smiling shape. Coordinate, component number 2, which is this y-intercept. Your y-intercept is equal to C, which is 3. Now you know that it's 0, 3. You already get that. The third component, which is the x-intercept. How to know the x-intercept? Press it in the calculator. I'm going to use this calculator. The value of A, original value of A equal to 1, B equal to -4, and C equal to 3. What will you get? x1 equal to 3. All right, x1 equal to 3, and then x2 equal to 1. You already get that. How about to find your minimum point, because this is smiling, by using negative b over 2a. Negative b over 2a, which is negative. Your b is -4. Okay, -4 over 2 multiplied by a, which is a equal to 1. So you get +4 over 2, which is 2. Now how to find the k value, all right, or the y coordinate here, which is k equal to, put it back everything in the initial equation. So 2 squared minus 4 multiplied by 2 and plus 3. So what do we have? 4 minus 12 plus 3 here. What do we have here? This one you can press in the calculator. How to get back to the original mode? Repress mode and then 1 here. 4 minus 12 plus 3, you get -5. Okay, all right, so you're going to get -5. So the coordinate must be 2 and -5. Try to pinpoint everything first. Pinpoint all the coordinate here first, which is must be smiling, which is here must be 0, 3. Imagine that this is 3 here, and then here is actually 3 and 1. Imagine that this is 1 and this is 2, this is 2 and this is 3. Just imagine. So it must be happen at 1 and 3 here. So you make like a dot or a small cross, and then the minimum point happen at 2 and -5. So this is 2, I make this dotted line, and imagine that -5 is here. So when the -5 is here, it's supposed to be here. It's supposed to be here. But remember, the graph cannot be in the y and the y negative value. So when you reflected back -5 here, then the reflected, it will be 5 on top. So it's still going to be on top here than here, like that. So how your graph looks like? Your graph will look like this. Initially, your graph will look like this. Okay, I'm going to draw the initial graph first, and I just draw the dotted line. It's supposed to be a smiling here. Then it goes back to 3 here, imagine, and then like that. But since that we don't want the negative value in the graph for y coordinate, so we reflected back here, then the graph will look like this. So that's how we do this, the sketching the quadratic modulus graph. I hope that you are clear with this. Just follow all these things. Just make sure that you reflected the graph towards the top by imagine that x-axis is your mirror or the symmetry line. Okay, I hope it's clear. And also, can the modulus graph be a sad face? It can be the sad face. How do you show me your... Show that px squared, show that the root of px squared plus p minus qx minus q are real for all real values of p and q. That one here is actually another step, which is that is actually a real value. So that one later. Okay, but it's a good question here, which is show that the roots of px squared plus p minus q, x minus q is equal to 0 are real for all real values and p. That's actually very, very good example, but later. But for now, here is actually a modulus here. I hope that you are clear with this modulus. So when it comes with this modulus, they for sure that they're going to ask you that the number of intersection or the number of solution, which is the number of solution here, they're going to ask you how many number of solution. Draw the line or find the value of k where the number of solution is 3, where the number of solution is 4. Find the range value of blah 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 that the solution is 4, something like that. Okay, so please remember that the number of solution is also equal to the number of point intersection between the y line and the graph, which is your smile or sad face graph or your modulus graph. What does it mean by y line? Here is back to basics. Y line here is that the line is horizontal line and parallel to x-axis. The way we write it as y equal to -1.5, just imagine like that. That is a y line. But if it's an x line, it's vertical, which is parallel to y-axis. As an example, I wrote here is x equal to 3. That is the x line. Okay, so for this example here, oh, this one is a bit a lot, but I don't want to show it to you here. It's a bit a lot. I don't want to consume much of your time. You have so much, you have not much of a time to study on your own here. I'm just going to use this example. So by using this example here, as you can see that whenever we are talking about the y line, please always understand that the y line could have 3 type of solution or 3 type of intersection. If your y line is around here, imagine, okay, just imagine that I extended the graph like that. So if your line is around that area, you only have 2 solution, which is 2 intersection. So what you can understand here is that when y is more than 5, which is the y line is more than 5 here, you only have 2 solution. Okay, you only have 2 solutions. So they may ask you what is the range of y value that it have only 2 solutions. So it must be more than 5 here. But what if exactly at 5? If exactly at 5, you must know that it have 3 exactly solution. So when y is exactly at 5, it have 3 exact solution. Okay, all right. And then after that, what if it's actually less than 5 and more than 0 here? Which is, it can be anywhere here or anywhere here. So when both this example here, which is y can be less than 5 and can be more than 0, that's where the point that it have 4 intersection of point here or 4 number of solution. So over here, understand that when that region, we have 4 solutions. And when y is back to 0, we're going back to 2 solutions. When y is going back to 0, you only have 2 solutions. So that's how I try to help you in understanding these things in terms of number of solutions. Okay, I really hope that it is clear. All right, I really hope that it is clear. Even if it's not clear, the live comment here, it's a bit delayed, and it's not lagging, but it's a bit delayed. I'm truly not sure on how I should respond to it. Okay, it's a bit delayed. I don't know how to make it in the real time. Or maybe after this, you know my Discord. Just share it in my Discord. I'll try to explain it through my voice note or voice message. Okay? Why y equal to 0 is 2 solution? Because y equal to 0 here is actually I only have two intersection, which is at 1 here and at 3. That's the reason why it only have 2 solution. It doesn't have 3, it doesn't have 4, but it only have 2 solution. That's the thing. And what does it mean by solution? Go back to here and just backward the video. I just explained it. Number of solution means the number of point of intersection between y line and the graph. So that's the thing for Modulus graph. I hope it's quite okay. Even if you don't understand, try to replay this video again and again and again. Now I'm talking about the next thing, which is quadratic inequalities. The question must have this kind of thing, the quadratic inequalities. What does it mean by inequalities? It's the region that satisfies the condition of that inequalities. So that's the thing, region that satisfies the y coordinate inequalities. We have 4 types, which is the 4th type here is either ax squared plus bx plus c more than 0, ax squared plus bx plus c less than 0, negative ax squared plus bx plus c more than 0, or negative ax squared plus bx plus c less than 0. Before I explain everything here, I want you to understand. It's just the tips to understand here. We know that y equal to ax squared plus bx plus c. This is the thing, y equal to ax squared plus bx plus c. And when they say ax squared plus bx plus c more than 0, it also means y must be more than 0. So y coordinate must be positive. Right, must be positive value, because it's stated here y must be more than 0. So that means the region that satisfies the inequalities, it must be around here, must be on top here. Alright, either left or right, or either in the middle, I'm not sure, but it must be on top of that. Since that is actually y coordinate must be 0, must be more than x here. Okay, I hope that is clear. But what if they say negative or negative later? But here is actually, what if they say less than? Same thing. Y less than 0. If y less than 0 means that y coordinate must be negative. Alright, must be negative. So if it's negative, the region that satisfies, it must be around this region. Must around this area. So that's how you can make it clear on these things. Alright. I hope you can clear with these things. I really hope that. Yeah, I really hope so. Even if you're not, try to ask someone to help you, or try to just replay this video. So on these things here, let's look on this, the first example. When ax squared plus bx plus c more than 0, it's stated here y is more than 0. And if it's smile shaped graph here, smiling graph here, just remember this part of the formula is part of the shape here. If it's smiling, it must be on the outside of the graph, but it's still on top. It's still on top of the graph, on top of the x-axis, but it must be outside of these things. Outside of what? You can see the roots here, which is p and q as roots, or the x-intercept. So x region that satisfy that inequalities. So x must be more than q here. If your value is, your x-intercept is 5, so x must be more than 5 towards the right. And over here, x must be less than p, which is towards the left here. That's how you understand. It's just part of the formula, part of the thing, part of you to memorize how we understand. Alright, but if we have the graph is a set face, which is negative ax squared plus bx plus c. which is if the graph is a sad phase and is say more than 0, so the y must be still positive. The y must be still on top of the x-axis. So the region that satisfies the inequalities is the region is on top here, and it must be between P and Q. So your answer must have this format here, which is x must be less than Q and x must be more than P. You just remember these things. Yeah, I'll make it smaller here so that you can straight away screenshot this thing, take a picture, just memorize this thing. Every time when you do the question, you just follow this method. Okay? Alright, what if the smile graph, but it is less than? So you have a smile graph and the less than, so the region of y coordinate must be underneath the x-axis, so it's between the P and Q here. The format of your answer must be like that. X is less than Q and x more than P. Okay? Alright, but if it's a sad phase and it's less than 0, it must be the y is negative, so it must be on the outside here. So the way you write answer here is x more than Q and x less than P. This is the format of your answer. So the way that the one that I put with black color is the format of your answer. Okay? Alright. Can explain the difference between y, fx, gx. Exact. That's actually supposed to be in function. But I want you to understand here, this is actually a bit of Malay, if you do understand. Yeah, as an introduction of function here, that's a bit of introduction of function, is that in a function, we want to get from one value to another value. So which means from the left value to the right value. So all the left value here, or before we do the transformation, or before we apply the function or apply the formula, all the thing here we name it as object or x here. So here I call it can be called as object. It can be called as domain. It can be called as x value. It can be called as x coordinate. It also can be called as x. But when it's already applying the function and the value now has been changed, has been transformed, it called as image, it called as codomain, y value, y coordinate, fx or y. So fx and y is the same thing. Fx and gx and y is the same thing. I hope that's clear. Okay, I really hope that's clear. So that's the thing. So that is the quadratic inequality and a bit explanation of the function between fx and gx. So this one later I'm going to show it to you. I'm not going to show it to you that much. That's not really truly an important thing. Okay, later the last part is the most important thing. So what does it mean? Next thing is type of roots. Okay, so type of roots here, like I told you, roots is the x-intercept. So we can have three types of interception. The first interception here is that, not the first intersection, the first type of roots here is that when you have two intersecting points. You can see properly here, which there are two intersecting points here or two x-intercept. When it's two x-intercept here, the keyword can be written as two distinct points or two real roots. It's still going to be real, all right? Or they're going to call it a two intersecting point. So the keywords here is real or distinct point or distinctive or another kind of word. It's explained that actually have the same meaning as distinct and everything or different. So that is the first interception or the first type of roots. The second type of roots is only have one interception, where this one here they call as equal roots, because it's supposed to have two, but two of that is equal. Imagine if this is 3, so it may be written as x equal to 3 and x equal to 3. Okay, why is that like that? Because later you're gonna have a expansion of a quantity in terms of x minus 3 equal to 0. You're gonna have x squared minus 6x plus 9 equal to 0. That is the example of equal roots. Another keyword here, they're gonna call it as tangent. Equal roots, tangents, the same thing. So that's the second example. And the third example here is there's no real root. There is no intersection at all. No real root. What does it mean by no real root? Because you may have an imaginary root. That's why the two real and imaginary are opposite to each other. But you're not going to learn imaginary. You're going to learn about real only. So just imagine that on the third example is there's no intersection. So what does it mean by b squared minus 4ac and everything here? It means as a discriminant. What does it mean? Or determinant, what does it mean? It means it's just an equation to check the number of intersections in a quadratic. Because when given the equation graph, or when given the quadratic equation here, they are not, wait, less than and equal, is it what you mean? Alright, there will be, no problem. Okay, there will be. Okay, but over here as an example, like I told you, when they give you an quadratic equation or quadratic form or anything, they're not going to give it to you the graph. When they're not going to give it to you the graph, how you want to imagine that your graph looks like what? Is it there is a two intersecting roots? Is there only have one root? Is there only have no root at all? So that's come with b squared minus 4ac here. If it's more than 0, you check that if it's more than 0, it have two intersecting points. If it's equal to 0, it have equal roots or only have 1 point. But if less than 0, that means there's no roots or there's no intersection. So let's see this example, which is if we have here, what is the value of a equal to 1, b equal to 4, and c equal to 4. So by using the b squared minus 4ac, b squared minus 4ac here, which is 4 squared minus 4 multiplied by 1, and multiplied by c here is equal to 4. So here we have 16, and minus 4 multiplied by 1 is minus 4, and here multiplied by 4 we still get 16 minus 16. What do we get? 0. So if b squared minus 4ac equal to 0, what can you understand here that the graph, it must have only one intersecting point. Yeah, the graph only have one intersecting point. So here we call it as equal roots. That's what it means. Okay, alright, that's what it means. So on the next example, the same thing. So here is just to check the number of intersections. But of course, the question not gonna ask you to check. The question already gonna tell you how and what kind of nature of the roots, and they ask you to find the unknown. As for an example here, find the set value of k for which 4x squared minus 4kx plus 2k plus 3 has no real roots. What does it mean by no real root? It must be b squared minus 4ac less than 0. So identify the value of a, b, c here. A equal to 4, b equal to negative 4k, and c equal to 2k plus 3. Okay? So once you have that thing, apply this thing, this determinant here. So b squared minus 4ac must be less than 0. So b squared is what? Negative 4k squared minus 4 multiplied by 4, and c is equal to 2k plus 3 less than 0. And when you expand this thing, it's going to be negative 4 multiplied by negative 4, which is 16. K multiplied by k squared. And here we got negative 16 multiplied by 2k plus 3 less than 0. So 16k squared, negative 16 multiplied by 2 is supposed to be negative 32. But if you're not sure, just press in the calculator. Sometimes I'm also not sure. Okay, alright, so here is going to be negative 32. Negative 32k, and negative 16 plus multiplied by 3. So negative 16 multiplied by 3, negative 48. And yeah, we're going to have like that. So when you have like that, this is the time where you need to apply the quadratic inequalities. You know what's the value of a here? A equal to 16. Over here, b equal to negative 32. And c equal to negative 48. What is a? A is a positive. So it must be smiling. And if it's less than, then if it's less than smiling, refer back to my quadratic inequalities. If it's smiling, and it is set smiling, and then it less than 0, so it must be, it must be this region. And how to find these roots here? Just press everything in the calculator, which is a equal to 16 here. Go back here, press mode. I'm going to show it to you here. Press mode and then find equation and the quadratic, and then just insert the value of a, b, c over here, not the top one, the bottom one here. 16, negative 32, and negative 48. No need to simplify. Even if you simplify, the answer is going to be the same, which is 3 and negative 1, which is, you know that the value of k is either 3 or k negative 1, or the interception. Okay, it's not k, sorry, it's the x value here. Okay, which is the intersection, either, what is it again, negative 1 or 3, right? Yeah, so negative 1 here is a 3 here. So what can you understand that what is the value of set value of k? So k must be less than 3 and k must be more than -1. That's how you understand. And that is the answer. That's your final answer here. Okay, when you check your final answer like this, you're gonna get this answer, you're gonna get these marks. All right, so I hope it's clear. All right, I hope it's clear. That's how we do these things. And the last one, which is the intersection of two lines. All right, where the intersection of two lines here is the part of the equation, the part of the question where they're gonna ask you to substitute first and then after that apply everything. So please remember, the way we do this thing here, it's almost similar to Pois's question, which is ask you to substitute and do simultaneous equation. So I already put the steps here. There is an example below that you can apply my steps. And this video will be uploaded later. I mean, like, this live will be, you can play the live here, the live video here. But the class video, the discussion will be uploaded on the next day in the playlist. So step number 1, substitute linear into nonlinear equation. That's obvious. That's almost like a Pois or simultaneous equation step. Rearrange it to become ax squared plus bx plus c. Identify the value of a, b, c. Then you apply the type of roots or the nature of roots formula. Either b squared minus 4ac more than 0, equal to 0, or less than 0. Then you apply the quadratic inequality if you have any. So let's look at this example. The curve y equal to 2x squared plus k plus 4 intersect the straight line. This is the curved line and this is the straight line. Y equal to k plus 4x at two distinct points. What does it mean, two distinct points? B squared minus 4ac more than 0. Find the possible values of k. What is my first step? Substitute linear into nonlinear. What is your linear? Y equal to bracket k plus 4x. What is your nonlinear? Nonlinear is y equal to 2x squared plus k plus 4. Substitute linear into nonlinear. This is linear into nonlinear here. So your y is equal to k plus 4x equal to 2x squared plus k plus 4. Alright, then you rearrange everything here. I move everything to the right side, so I move it to the right side because I always love to make my a's positive because you rearrange it. 0 equal to 2x squared minus bracket k plus 4x plus k plus 4. Alright, okay, so in this kind of thing here, you should know that this is your value of a. Once you already rearrange it, your a equal to 2, your b equal to negative bracket k plus 4, and then c is equal to k plus 4. Alright, that's how we do. So after you already rearrange, after you identify the value of a, b, c, here's the part where you need to apply the type of roots formula. B squared minus 4ac more than 0. If it's more than 0, then you apply it. B squared minus 4ac more than 0. You either can do it below here or you can do it on the left side here. So I will do it on the left side because I have more free space on the left side here. B squared minus 4ac more than 0 because two distinct points. Then you apply everything in the calculator. What is your b? This one you can expand it first. Negative k and minus 4. So you're going to have negative k minus 4 square. Minus 4 multiplied by a is 2 and multiplied by c is k plus 4. It's more than 0. Expand it. I'm going to expand it quickly here. You can expand it manually, but I'm going to expand it quickly. Negative k multiplied by negative k is positive k squared. Negative k multiplied by negative 4 is positive 4k. Multiplied by 2 is positive 8k. And negative multiplied by negative 4 is positive 16. And here we got negative 8. K plus 4 more than 0. K squared plus 8k plus 16. Here minus 8k and minus 32 more than 0. And rearrange it and apply the quadratic inequalities. Right? How do you apply it? Rearrange it first. So k squared plus 8k minus 8k plus 16 minus 32 more than 0. So k squared, 8k minus 8k is 0k, 16 minus 32 and minus 16 is equal to 0. So this graph here, from this equation, what is the value of a? A equal to 1, b equal to 0, c equal to negative 16. If a is 1 positive, it must be smiling. And if it's more than 0, it must be outside here. Remember that is part of the formula. Find the x-intercept or the roots here. How to find it? Press in the calculator. How do you do it? Press mod 3 times, find equation, find degree equal to 2 and a equal to 1, b equal to 0 and c equal to negative 16. You're going to get that x front equal to 4 and here negative 4. So 4 and negative 4. How your answer is going to be? Your answer is going to be that the value of k, not x. Because they say here, find the possible value of k, which is k must be more than 4 or k is less than 4, negative 4. And that is your answer. Because usually this kind of question, of course, is going to take you a lot of marks, which is over here at the bottom here is actually 6 marks. It's the same thing. Substitute linear into nonlinear. Rearrange it to become ax squared plus bx plus c. Find the value of a, b, c. Apply the quadrant. Apply the inequality. The determinant formula, the type of roots formula, which is when they say do not intersect, it must be b squared minus 4ac less than 0. Alright, you already identify a value of b, a value of b, value of a, value of c. Apply the b squared minus 4ac less than 0, and then do the quadratic inequalities. Do the same thing all over again and again and again. That's the thing. Okay. No need factorize. If we straight away use calculator, 1 minus a mark, it's like we skip one step and straight away got the solution. No proof of getting the solution and not following the marking scheme. Is it true? No. Alright, here's the thing. When I look at the marking scheme, it doesn't say anything not from wrong working. It doesn't say the code of NFWW. So you can use any method, but it's actually supposed to be the same. So even if you're scared of using the method, of using the calculator method, how do I put it here? Even if you're scared to use the method, for an example, if I give it to you, x squared minus 6x plus 9. You wanted to know your value of x, right? Okay, just imagine it's equal to 0. You wanted to know your value of x, but you're scared of using calculator, you won't get the marks. I'm going to suggest you still use the calculator, which is if you use the calculator, this thing you're going to get 3a equal to 1, b equal to negative 6, and c equal to 9. You must have x1 equal to 1, x1 equal to 3, x2 also equal to 3. So what you do here, leave some space. X equal to 3 and x equal to 3. Leave some space. You leave all these spaces here and straight away put your answer below with the allocated space there. And what you need to do on this empty space, you pretend like you are using the formula, but you're not. You pretend like you are doing the formula, but you're not, because that's going to cost you time. Okay? So you still may get the marks because of you pretend like you are using the formula. Alright, so how do you do here? Which is on these things, let me show it to you. Let me show it to you here. You just pretend, first of all, find the value of a first. A equal to 1, b equal to negative 6, c equal to 9. And then after that, you write down the formula first. X equal to negative b plus minus b squared minus 4ac over 2a. Then what you do, you substitute all the value of a, b, c inside the formula. X equal to negative bracket negative 6 plus minus b squared, which is negative 6 squared minus 4 multiplied by 1 and multiplied by 9 over 2 multiplied by 1. And that's it, you're working. And straight away, that is your answer. If you're scared of missing the marks, the working is there. Okay, the working is there. So I just hope that the mark is still given to you with this kind of pretend working. You're not doing the formula method, but you are doing the calculator method. But you act or you pretend like you are doing the formula method. I don't think that's going to be a big problem. What I think is that your answer is correct. It's still going to give you a correct answer. It's still going to give you a correct marks. When the answer is correct, it's correct. Unless the marking scheme going to say to you, which is NFWW. You go look at the marking scheme, go look at the internet. There will be a past paper, IGCSE past paper website. Go have a look at the marking scheme for AdMed. There will be a code of NFWW, which is NFWW is N not from wrong working. If it's not from wrong working stated in the marking scheme, then you cannot use a wrong working. You must use a correct working. If not, your answer, even if it's the same answer, even if it's actually the correct answer, your marks not going to be counted because not from wrong working. But for here, I never see any kind of quadratic put it as NFWW. Alright, I just hope. Yeah. So, if we are finished here, that would be it for our live video session of revision chapter 2. I just finished it and I think I already finished it in 1 hour. Maybe 1 hour, maybe less than 1 hour. But yeah. That's all the thing in chapter 2, quadratic, nothing much. So, I really hope that tomorrow you can do it well. Make sure you have a highlight on how to study on sketching. First of all, of course, I think everything lah. Nonlinear simultaneous equation, quadratic vertex form, and then sketching the quadratic graph. Okay, this 4 component. Sketching the quadratic modulus graph, including with the number of solution here, which is all these things. And lastly, the intersection between 2 lines. When the intersection between 2 lines here, there will be the type of roots application, b square minus 4ac, and there also would be the application of quadratic inequalities. Okay, the quadratic inequality you guys are always confused about. Let me give you a very simple example. For an example, this here, x squared, I move 4x to the left side, and 12 to the left side, so it becomes minus 4x, and minus 12 less than or equal to 0. Here is less than or equal. So if it's smile graph, okay, if it's a smile graph, and less than equal, it must be on these sides. And how you want to know the roots here? Press in the calculator. A equal to 1, B equal to -4, and C equal to -12. You're going to get that 6 and -2. So imagine that this is 6 and this is -2. If it's less than or equal, so your answer is x less than or equal to 6 and more than or equal to -2. That's all. Nothing much. Okay, that's all for the working and that's all for the answer. I hope you guys can study, and I hope that this live video can make your life easier and make your understanding better. Don't drop the subject. Oh, don't drop it. Actually, at math it's easy if you have the right explanation, and if you have the right notes and you have the right focus. At math is easy, trust me. Okay, I still remember my student named Brandon Wee Yongjing. He is so smart, and he said that at math is easy. And yeah, I hope that he's doing well now. And yeah, that's all for today's class, and that's all for today's live session. Like I said, I hope that this video helped you guys. So please have a good study. Thank you so much. Good luck for your tomorrow exam. Okay, I'm gonna end the live stream now, and thank you so much. Teacher, the question I sent in your Discord, what's wrong with it? Oh yeah. Oh yeah, before I left the thing here, show that the roots of px square, everything here are real. What does it mean are real here? Must be b square minus 4ac more than 0. So what is the value of a here? A here equal to p, b here is equal to p minus q, and c here equal to -q. Apply the formula here, show that. Okay, if it show that here, is actually you need to put b square minus 4ac more than 0. But yeah, this one is kind of confusing. So b square minus 4ac more than 0 here, which is it must be p minus q square minus 4 multiplied by p and multiplied by -q. So what you're gonna have here, p square minus with 2pq and plus with q square minus with plus is 4pq. It's supposed to be more than 0, but in this kind of thing, what makes this the question are real here? Show that the roots are real for all real values of p and q. So what do we have here is p square minus plus with 2pq plus with q square more than 0. This kind of thing. Even if we factorize it, I'm not truly sure on these things. Okay, you better go look back on the marking scheme and try to apply this formula here whether it can correct it on the answers that you have it. Okay, but I don't think this question is gonna come out. This is so confusing. It doesn't give you much information for your level right now. Okay, so yeah, I hope it's clear, and I hope that all my explanation just now is clear. So thank you so much. Go have a study. If you have some question, you can ask me on Discord if I haven't slept yet. But yeah, that would be it for today. Thank you so much, and goodbye, good luck, and bye bye.